Hi, we're going to talk about calorimetry now, and that is the science of measuring heat flow. So first of all, I want to be sure that you know the difference between temperature and heat. You need to know these definitions. Let's talk about temperature first. Temperature is a measure of the average kinetic energy of the particles that are in the matter. So if you've got a high temperature, the molecules are moving faster, and so you have a higher kinetic energy. Remember, kinetic energy is the energy of motion. So at higher temperatures, our molecules are moving faster. At lower temperatures, the molecules are moving slower and have a lower kinetic energy. That is what temperature is. It's a measure of the movement of those molecules. You can think of it as the kinetic energy. Heat, on the other hand, is energy that is transferred between samples because the matter is at different temperatures. So, heat will always spontaneously move from things at high temperatures to things that are at low temperatures. So, heat is energy transfer. The symbol for heat is a Q, and the SI unit is joules, and that has an abbreviation J. And you can put prefixes on it, so a lot of times you'll see kilojoules as a unit for heat. Also, another unit that's used is calorie, and that should sound familiar to you, like the calories in food. And actually, the food calories are actually kilocalories. In this class, you're just going to be seeing joules as a unit for heat because the SI unit for energy is joules. So here we've got a piece of hot metal and we're placing it in cold water. So what's going to happen, and I think common sense, you would know that the metal is going to cool down and the water is going to warm up. And that will happen, so we'll have this heat transfer from the hot metal to the cold water until they both reach the same temperature. Let's talk about what's happening to our piece of metal. So that piece of metal is going to be cooling down. So its kinetic energy, so I'm going to write it as Ke, the kinetic energy of the metal is going to be going down because it's cooling down. But what about the water? The water is heating up, so the temperature of the water is going up, and so the water's kinetic energy is going up. Okay, so again, it's a transfer of the energy from the hot substance to the cold substance, and we're going to be seeing a temperature change in the metal and the water until they reach the same temperature. All right, so this quantity of heat that is transferred depends on three different things. It depends on how much you have. The more you have, well, the more molecules you have, and so the greater the heat that they could contain. It's also going to depend on the nature of the material that's changing temperature. And we're going to talk about that. It's called specific heat. And we're going to talk about that more in some slides coming up. But, you know, some things just seem to heat up faster or cool down faster. I know in the summertime, the sliding boards, if they're made out of metal, they get hot really fast. The ones that are made out of plastic, they don't get quite as hot. Okay, and the other thing that this quantity of heat depends on is just how much of a temperature difference is there, and we call that delta T. Okay, so Q stands for heat, so let's remember that. Q is heat. Our unit is joules or kilojoules. M is mass, and a great unit for mass is grams. C is our specific heat, and we're going to talk about it in the next slide. And delta T is our change in temperature, and that change could be in degrees Celsius or it could be in Kelvin. All right, so this is an important equation, and it is in your reference packet. Q is equal to mc delta T. Some people call it the MCAT equation. Also, I have seen a lot of places where the Q is a lowercase q as well. All right, so what is this C? What is this specific heat? Well, the definition is the amount of energy required to raise the temperature of 1 gram of the substance by 1 degree Celsius or 1 Kelvin. All right, well, the units are joules, the amount of energy, so that's a joule, required to raise the temperature of 1 gram per gram of a substance by 1 degree Celsius or 1 Kelvin. So what that really means is specific heat. It's going to be a number that just tells us how well a substance absorbs heat. How many joules of heat do you have to put in order for a gram of it to go up a degree C? Okay. The specific heats are different for different substances. Again, specific heat. How well does a substance absorb heat? That's really what it is. Well, from your reference tables on page 1, here are these different metals that they've listed, and they've given you their specific heats. Notice here's the unit, joules per gram degrees Celsius. And as you can see here, aluminum specific heat, it looks like it's almost the highest. Magnesium is a little bit higher. That just means that it takes more energy to heat up a piece of magnesium than it does to heat up a piece of mercury. All right, specific heats. These are values that would be given to you, or they're in your reference tables. Now, we're going to be using specific heats of water. And so this also came from your reference table. The specific heat of water, or capital C, and they put a little p in there, of water. And look at this. It's different depending on the phase of water. So for ice, it's 2.05. For steam, it's 2.02 joules per gram degree C. And then for liquid water, it's 4.18 joules per gram per degree C. That's the highest specific heat that we've seen so far in this video. So this is a high specific heat. And what that means is that water is good at absorbing heat. So water can absorb heat very well. And we've actually talked about this when we talked about diluting acids. Remember when we dilute an acid in water, we said to always add the acid to the water, the AAA. Always add the acid to the water. And that's because you'll have that amount of water in there to absorb the heat that will be generated. Also at a nuclear power plant, that big cooling tower, that's water to cool the nuclear reaction. That puts off a lot of heat. So water specific heat is high compared to other substances, and be careful when you're working with water. Make sure you look, are you working with ice, are you working with steam, or are you working with liquid water? So now what we're going to do is we're just going to practice some problems using our equation. Q is equal to mc delta T. So this question asks for how much energy or how much heat, so we're solving for Q, is required to raise the temperature of 250 grams of water from 22 degrees to 65 degrees. Well, this 250, that's our M. Mass is, the unit for mass is grams. We're going to have to look up our heat capacity for water. And we're at 22 degrees Celsius, so this is liquid water. And if we look up its heat capacity, it's 4.18 joules degrees C gram, or grams degrees C, it doesn't matter. All right, that's not a minus sign, that just means both units are in the denominator. And how much is our temperature changing here? We're going from 22 to 65, so we're heating it up, let's see, 43 degrees Celsius. Okay, all we have to do is plug those numbers in, we multiply them together, and we will get the amount of heat that we need to raise our water from 22 degrees to 65. All right, so 250 grams. The heat capacity, 4.18 joules per degree C per gram, and 43 degrees Celsius. This 4.18 came from your reference packet for liquid water, the specific heat of liquid water. And I think that is also on the front page of the reference packet, just so you know where to find these things. Let's have a look at our units. Grams here, grams down there, degrees C in the denominator, degrees C in the numerator, leaving us with the unit joules. That's the right unit for a heat or for energy. So when we multiply 250 times 4.18 times 43, let's see, our answer is 44,900 joules. Now sometimes in multiple choice they'll leave it like this, or sometimes they'll put it in scientific notation. And that would be 4.49 times 10 to the 4th joules. So review scientific notation, because sometimes in multiple choice questions they'll put the answer like that. So, or we could have reported it in kilojoules. This question required it in joules, but in kilojoules we would have divided our joules by 1,000 and it would have been 44.9 kilojoules. Okay, now we can also solve for the mass. So here they're saying that a quantity of water is heated from 20 degrees to 95 degrees. So here we're talking about liquid water again, because at that temperature range, it is liquid water. During the process, we know how much heat we've added, and we added 125 kilojoules. How many grams of water is heated? Okay, Q is equal to MC delta T. How many grams we're solving for M? So get M on one side by itself by dividing both sides by C delta T. And so see, it cancels here. So our mass is equal to Q divided by C delta T. Okay, now the C for liquid water is 4.18 joules degrees C gram, or grams degrees C. All right. That's joules, but they gave our heat in kilojoules. So let's convert kilojoules to joules so that our units will match. So 125 kilojoules is 0.12, whoops, I went the wrong way, my goodness, 125,000 joules. Okay, 125 kilojoules is 125,000 joules. All right, so in our numerator, we have 125,000 joules divided by the heat capacity of liquid water, 4.18 joules grams degrees C, and our temperature here is changing by 75 degrees. Our units are all going to cancel nicely. See, the joules and the joules and our degrees cancel, and we will be left with the unit grams. And make sure you do this on your calculator. You're going to need to do 125,000 divided by parentheses 4.18 times 75. And let's see, this answer I come up with is 399 grams of water. So we've just used our equation, and this time we solved for the M.